Right. So let us see few examples. So what is that we have seen? We have seen that the condition for faithful reproduction is what? 1 by t should be greater than or equal to 2b. So if you know the bandwidth of the signal, you can know the sampling rate. So whatever we have seen before, right? For all those signals, what will be the Nyquist rate here? It is just twice the bandwidth of the signal. So for example, so if you remember our bandwidth of a signal, so we have seen lot of examples, right? For all these signals, what will be the Nyquist rate? For all these signals, what will be the Nyquist rate here? It is just twice the bandwidth of the signal. So we will take first example. So we want to find the Nyquist rate of this signal. So what is the signal? X of t equal to sine 100 pi t by pi t. So Nyquist rate depends on what? Nyquist rate depends upon the bandwidth of the signal, and hence we have to go into frequency domain, and this is our x of j omega. So we already found out that the bandwidth of this signal is how much? 50 hertz. So what should be the Nyquist rate? Nyquist rate for this signal. So first one, Nyquist rate should be equal to how much here? It should be equal to twice the bandwidth, which is 2 times 50. This should be equal to 100 samples per second, or you can say 100 hertz, but we will just say it is 100 samples per second. Okay, so same is the case here. So what is the Nyquist rate for this fellow? So I'll say n for Nyquist rate. Okay, I'll write here. So what is the Nyquist rate for this signal? That should be equal to 2b again, which is equal to 2 into 100, which is equal to 200 samples per second. Okay, that is the Nyquist rate of this signal. And what is the Nyquist rate of third signal? Bandwidth is, third signal is what? Sine 4000 pi t by pi t. So that fellow will have a bandwidth of 2000 hertz. So what is the Nyquist rate here? Nyquist rate is 2 into 2000, which turns out to be 4000 samples per second. Okay, so 4000 samples per second. Okay, in a similar way, we can see Fourier, bandwidth of all the signals. We know bandwidth of all these signals. So what is the Nyquist rate? So it is just twice the bandwidth of the signal. So for example, you take this. So what is, after doing all the algebra, so we got bandwidth of this signal to be how much? 2000 hertz. So what is the Nyquist rate for this? Nyquist rate would be 2 times 2000, which is 4000 samples per second. Okay, so 4000 samples per second. Okay, similarly, what about this fellow here? This fellow, x of t equal to sine 4000 pi t by pi t multiplied with sine 2000 pi t by pi t. So first thing, you have to find the bandwidth. You cannot escape. So after finding the bandwidth, then you have to find the Nyquist rate. So bandwidth is, we found it to be how much? 3000 hertz, and hence Nyquist rate should be equal to 6000 samples per second. Okay, 6000 samples per second. And like that, you can find out the Nyquist rate for all the signals what we have seen. So for example, as a last example, we'll take this one. So sine 4000 pi t by pi t whole cube. So as I said, we have to first find the bandwidth, then we have to find the Nyquist rate. So we have already found the bandwidth of this signal to be how much? 6000 hertz. And hence what will happen to the Nyquist rate? So Nyquist rate should be equal to n equal to 12,000 samples per second. Okay. So for faithful reproduction of this signal, which is sine 4000 pi t by pi t, you have to sample it such that you have how many samples in 1 second? In 1 second, you require 12,000 samples. Then only you can reconstruct the signal back. Okay. So remaining signals, whatever we have seen, I will leave it as homework. So wherever you find the bandwidth, you multiply that with 2. That will give you the Nyquist rate, but units you will keep it as samples per second. Okay, so all these questions, whatever we have seen previously in bandwidth of a signal, you please write down the Nyquist rate. So let us take that as homework. Okay, so with that we are done with sampling theorem, and next let's move on to the last topic of continuous time Fourier transform, which is LTI systems. Okay.